You're listening to Bottomshelf Bitcoin, episode 25.
Relax. Enjoy your coffee. Okay. Good morning, everyone. Take a chill pill. What is it? Okay.
Hey everybody, welcome back to another episode of Bottomshelf Bitcoin, the podcast that puts Bitcoin knowledge within everyone's reach. As always, I'm your host, Josh Humphrey, and joining me today is Adam Gibson, maintainer of JoinMarket, and we're going to talk about CoinJOINs and mixers and privacy and all kinds of stuff. So, Adam, welcome to the show.
Thank you for having me. Nice to be here.
Yeah. So, tell us a little about yourself and kind of what your background is and what got you into Bitcoin.
Sure, yeah. Well, my background's a kind of a mixture, a bit of engineering, a bit of teaching, a lot of mathematics and physics, especially mathematics is kind of a love of mine. And I was a nuclear engineer, software engineer, short periods. And as I said, I did quite a bit of teaching as well. In terms of getting interested in Bitcoin, well, it was around like late 2012, early 2013 when I got interested. And it was a combination of both angles that interested me, both the kind of, open source money and potentially new model for a financial system. As crazy as an idea as that sounded at the time, it was appealing. But it was only really when I read the white paper and seriously attempted to understand it, which I guess was the beginning of 2013, that I realized the whole cryptography angle and how open source fits in and the sort of parallels with earlier open source distributed systems, things like, Wikipedia, BitTorrent, and it sort of all sort of clicked together at that point. And I realized this is something very serious, and it seemed to me to be a serious project that is worth getting involved in. And in that first year, I didn't really do anything particular in terms of Bitcoin apart from just learning about it, learning how to use it, learning how to buy it, and run the wallet, and all this sort of stuff. Learning a little bit about the internals, but I got sort of interested in a sort of related concept, which a project we called TLS Notary, which we were looking at, how you could try to support the concept of decentralized exchange by making the possibility of getting an independent proof of having visited a website, like a bank website. And yeah, it was kind of tangentially related because it was about cryptography and about TLS, how you can create different kinds of signatures. And I sort of more and more dived into the cryptography side of things over the last few years. And I dived more and more into Bitcoin itself. And nowadays, in the last few years, I've been really focused on Bitcoin privacy technology, both CoinJOIN, which we'll talk about, but also lots of other privacy tech as well.
So tell us a little bit about, and I don't know which one makes more sense to talk about first, CoinJOIN, the CoinJOIN concept, or specifically about JoinMarket.
Right, yeah. So if we're going to have a sort of deep dive or relatively deep dive into this stuff, I think we need to start with CoinJOIN, and we need to start with Bitcoin transactions because, I can't assume that everyone knows Bitcoin inside and out, right? So we should get the basics down, I think.
Right, exactly. I mean, that's kind of the point of this show is we're thinking the deeper stuff and trying to distill it down to the everyday guy.
Absolutely. So I'll try to keep it high level, but I want to make sure people understand the most critical central points. So the thing to get right in your head with Bitcoin, it's a bit difficult at first, is the kind of mental model of what a transaction is. So one is used to thinking of transactions in a kind of very vague way in the real world. I think one thinks of it as Alice pays Bob. There may or may not be change involved. I mean, if you're using like a Visa card or something, there's no change. You just make a payment, right? That's it. I pay $100. I pay $5. If you're using cash, then we're all used to the idea of there being change. We make change. And so if I've only got a $100 note, I get the 95 back. So that does happen in Bitcoin, that second model. that cash-like model happens. But it's actually even more. There's more to it than that. So think of it like this: it's as if when you paid you've got $100, and you're paying the $100, and you're getting a new $5 back. So it's almost as if you took a $100 note. Say you go up to a counter at a merchant, and you produce the $100 note, and that $100 note gets destroyed. It's like it's burnt up or it's cut to pieces. And there's two new notes that get created: a 90, which the merchant, 95, which you keep, and the 5 note, which the merchant keeps. So obviously that's not what actually happens with real notes, but in Bitcoin it's like that. I start off with something called a UTXO, and that just means unspent transaction output. And the reason it's called an output is because there was a previous transaction that created it. So let's say I've got a single UTXO worth 100 BTC. Okay, it's a bit big nowadays, but so I've got 100, but it's easier to use round numbers. I've got 100
Right,
BTC.
whole numbers are easier.
No dot, point, whatever. Get that. So I've got 100 BTC UTXO. I create a transaction that creates 2 more UTXOs. So it's kind of weird, this UTXO concept, because everything is unspent until it's spent. So this transaction, right? This is really confusing, by the way. I remember this when I first started learning. But a UTXO is like a coin, but it's like a coin with a variable size. So I've currently got this 100 BTC UTXO. Think of it as a coin, not a Bitcoin. It's 100 BTC, but it's a coin. And I'm going to make that the input to a new transaction, and there's going to be 2 outputs. Outputs of the transactions will be new UTXOs or new coins, and I decide what their values are. I just have to make sure they add up to 100 or slightly less. So I'll make one new UTXO, which is 95, and one new UTXO, which is 5. And I'll assign the ownership of that 5 to the merchant. So he gets 5. And I'll assign the ownership of that 95 new UTXO to myself. So I get back 95 in change. So notice in that model that it's like that weird example I gave just a moment ago, that the 100 BTC UTXO, which I'm consuming in this transaction, is in some sense destroyed. It's destroyed in the sense that it will never be able to be spent again, because the whole point of Bitcoin's blockchain is to prevent double spending. So that will no longer be spendable. And in the future, the 95 and the 5 will be spendable. So they are the new UTXOs that are created. So I'm going into almost painful detail with this. And the reason is that the first thing you have to observe is that this destruction and creation thing. And that's really important. It isn't very important in a typical transaction. The one I just described, the fact that the 100 is destroyed is not, and it's not that I gave the 100 to the merchant. Yeah? Notice the difference. The 100 is destroyed. That fact is not really important, because all we really care about is one guy got 5 and the other guy has still got 95. It's still the case. But CoinJOIN is a concept that makes that destruction element important. So let me explain why. So CoinJOIN as a phrase was introduced by Greg Maxwell in 2013 in a long post he made on the Bitcoin Talk forum. Because, back in the day, like 2013 and earlier at least, Bitcoin Talk was like the place people chatted about Bitcoin, technical or otherwise. So he made this long post, and it was really well explained. But what he was really explaining is something that was always true about Bitcoin, which is that you can use more than one UTXO or coin from your old transactions and put them as inputs to a new transaction. So instead of, I should build this up in stages. The next step is the same as before. The guy is paying the merchant. He's paying him 5. But this time the guy doesn't have a UTXO of 100 BTC. He has 2 UTXOs of 50 BTC. Hang on. Let's say he's spending 60. Yeah. He's not spending 5 anymore. He's spending 60. And he's got 2 UTXOs of size 50. So either one of them on their own is not enough to pay the 60. So he has to spend both. Now, it would be really clunky if he had to spend both of them in separate transactions. So what Bitcoin allows is for him to use both of those 50 BTC UTXOs as input to the same transaction. So 2 input coins in the same transaction. And then as before, there'll be a 60 output, which is to the merchant. That's what he's paying. And there'll be a 40 output, which is changed back to him. So in this case, I want to get this one right before we do CoinJOIN. Even in this case, it's important, the concept of destruction, because ask yourself the question, the 60 which the merchant receives, which of the 2 input UTXOs did that 60 come from? What's your answer?
Now, ask that one more time.
So he's produced 2 input UTXOs, both of 50 BTC. The merchant has received 1 UTXO of 60 BTC. Which of the 2 inputs does the 60 come from?
Well, it's a combination of both of them.
It's a combination of both of them, clearly. I mean, the question barely makes any sense, right? But no, I understand. It was deliberately a stupid question, but the point is that you can't say, oh, the first input, 50 of that went into the 60, and 10 of the second one went into the 60. I mean, you can say that, but can you see that it doesn't actually, there's no basis to make the distinction?
You can't prove that.
Right. Well, no, it's not even that. It's just there is no such distinction, right? Because the point is that's why I was talking about destruction.
Oh, right. Okay.
You see my point, right? Okay. There's another way to say it, which I think is much clearer, which is that Satoshis are not watermarked. You know, if I had 100 pennies and I was paying you 60 pennies, and I would have to choose 60 specific pennies out of the original set to give to you, right?
Okay.
But in this model, because the individual Satoshis, the individual parts of the Bitcoins, don't have like serial numbers, which you can then trace and say, oh, the 60 consists of these specific serial numbers. There is no such process, right? See, another way of putting it is that there are no such things as Bitcoins. It doesn't exist. It's simply a measuring unit. You see, what's happening at the transaction level is that all the verifying nodes are looking at the transaction, and the only thing they're checking is that the total of the outputs is strictly less than the total of the inputs. There is no, right, so there is no mapping between the inputs and the outputs. You can say that the first input of 50 went to the merchant and 10 of the second UTXO went to the merchant, and the remaining 40 of the second UTXO went to the second change output. You can say that, but there is no actual like place in the code that identifies which of the inputs ends up being in which of the outputs. Is that clear yet?
Yeah, because both of the inputs are destroyed.
Yes.
And so then you can't know, and there's nothing. Yeah, I get what you're saying. You're right though. This is a difficult thing to express in words.
It is difficult to express in words, and it's like against our normal intuition of money, because we either have the intuition like when we're using banks or credit cards that it's just a number that gets on a database, right? It's irrelevant. Or we have the intuition like coins and notes, right? And with coins and notes, I mean, notes have serial numbers, and coins, they don't really have serial numbers, but you could check there would be a way to check a difference between one coin and another, right? They're not literally made of the same atoms. So the point here is that this is a subtly but crucially different model, because and notice that this distinction only mattered when we had more than one input. Did you notice that? Because obviously if there was only one input, there's no question to ask, right? It all came from that input. So that's that. But with 2 inputs, if we want to assign which input ended up in which output, we simply cannot make that assignation. It's not, there is no such thing, because they're just, go on, yeah.
Does it help to think of it? I'm just, my hamster wheel, my head's spinning here.
Right.
What if we think of it, obviously no analogy is perfect, but like liquid, right? So we're pouring 2 cups at the same time, as each cup is an input, and you have 2 cups of 50. You're pouring them at the same time.
Yes, good.
And there's no way to separate.
Yes, that's good. A good thought. In practice, that's a valid analogy. Obviously, literally at the atomic level, there are distinct atoms in each.
Sure.
But in practice, that's a good way to think of it. I prefer to, because my background is mathematics, so I like to think of it. Sure. I just say, it's a many-to-many mapping. So, if that helps some people, maybe it does. But the other, I think, other nice physical analogy is destruction. When I was, excuse me, when I was in Lisbon, I gave the physical analogy of, imagine you had gold jewelry. You have multiple pieces of gold jewelry, right? And you assign them a certain value, whatever. If you just pour them all in and you just melt them all together, and then you've reforged new pieces of jewelry, you can't really say that one piece of jewelry corresponded to one old one, because all the atoms were just mixed together and every gold atom is the same as every other gold atom, right?
Right.
So it's in that sense. So what I call that is intrinsic fungibility. And finally, after God knows how many minutes, I'm actually going to tell you what CoinJOIN is.
No, that's good. That's good.
Because without knowing that, this I think it kind of glides past people what this really means. So Greg, I'll come back to that. So Greg Maxwell's CoinJOIN post in 2013 was an attempt to really elucidate how this can be used to improve the fungibility and or privacy of Bitcoin. So the idea is very simple. Instead of just me making a payment, what we've talked about so far, we have more than one person contribute these input UTXOs to a transaction. So let's say you and me, we're going to each provide, this is a completely made up example, but it serves the purpose. We're each going to provide 50 Bitcoins, as in the previous example. Instead of it just being me producing 250 Bitcoin UTXOs, I'm going to produce one, you're going to produce another. Or we're both going to provide them as input to the transaction, and then a payment. Let's say for some reason we agree to make the payment of 60 to the merchant happens, and then there's the 40 change then would have to be split depending on what our payment arrangement was, so our changes go out to both of us. Okay, so the first thing to observe about that description is, because of the intrinsic fungibility we've just discussed, it is not possible to say, at least given that evidence, at least, it's not possible to say who made the payment or in what division we made the payment. Actually, this is a bad example. I'll change it a little bit. No, because it really introduces a whole load of extra complicating factors. So,
okay, real quick though.
Go on.
I wanted to kind of point out for listeners, because this idea of inputs and change outputs and things, it like you say, it kind of confused me for a while. And this is, and I think part of it is, part of what's confusing is this. I talked a while back to Joakim Fernandez, and he said, there are downsides to the way we view this and use analogies of money. And when we use wallets, the user interface kind of does all of this stuff or it does it all in the background, and we don't see that unless you go looking for it.
That's
because
true.
A lot of times you just see at the top the total, and it adds all of your UTXOs together, and that's what you're seeing as your balance.
Absolutely, yeah, and that, of course, that's important, and at a user interface level, that's the correct thing to do generally. But perhaps we'll discuss later, the kind of friction between user interface and privacy here that arises. But I just wanted to correct that previous example, because I want to introduce CoinJOIN.
Sure, yeah, go ahead.
CoinJOIN properly. I think that would be a bad example to start with. The simplest example to start with would be, you give me you put in 50 coin UTXO, and I put in a 50 BTC UTXO, and let's say the output is really simple. It's two outputs of 50 BTC. So again, we've destroyed both of our inputs, and we've created two new outputs, or UTXOs, of 50 BTC each. And the first thing you should observe is that, let's say we paid back to ourselves. Yeah, I paid 50 just straight to myself, and you paid 50 to yourself. Those two outputs, nobody can know which one of those outputs is ours based on that information, because the two inputs are not linked to either of the two outputs separately, right? We talked about mixing or melting gold or whatever. Those two outputs, nobody can know which one is connected to which input. Now, that sounds all kind of cool, because it creates a situation where we don't know who owns what. But we have to make sure we understand the mechanics. Can we do that without trusting each other? Can you and I make that transaction without trusting each other? What do you think? Or if you want me to explain again, just let me know.
Now, can we make that transaction without trusting each other?
Did you get the scenario? Shall I describe it again? Or
No, I got it. I'm trying to think here, because the potential problem, I guess, and I guess it depends on what kind of software, what kind of client or whatever you're using to put those in. But my concern would be that I'm putting in my 50, how do I guarantee that I get 50 back and that you don't swipe that?
Right, absolutely, yeah. So it's important to understand this. So the answer is yes, it is completely trustless, but this is why. So what we do when we sign a Bitcoin transaction is we're actually signing our inputs. Sorry, I get this right. We're signing with the key of our input the whole transaction. So think of the whole transaction as a message which says these inputs, 1, 2, 3, 4, however many inputs, are going to provide the coins, and the outputs are going to be precisely this. Address 1, Josh, 50. Address 2, Adam, 50. Right? So when we sign the whole of that message, but we sign it with the key belonging to the individual inputs. So this is the workflow, right? It will start off, let's say I ask you for a UTXO. And all I'm doing now, I'm just asking you for information. So you give me the identifier of your 50 BTC UTXO. Okay. I say, okay, I've got your identifier, your UTXO. I'm going to build a transaction. And I also say to you, please give me an output address where you want to receive your 50 Bitcoin output. So you give me the address as well. Okay. I'm ready now. I can build a transaction. What I do is I put your input, let's say, as the first input, your UTXO 50 BTC, Josh, input 1. Then I build input 2, my own UTXO, Adam's UTXO 50 BTC, that's input 2. So then I build the second half of the transaction, which is the output. So I build address 1, Josh, whatever it was, 50 BTC, address 2, Adam 50 BTC. So I've now built the whole transaction, but it's not signed yet. Nothing can happen with it yet, okay, because we haven't signed it. If we put it on the network, it will be rejected. There needs to be signatures. So I look at that whole transaction and I sign with the key of my input. And I'm happy to do that because I know that if this transaction goes onto the network, it will definitely pay me 50 BTC. Agreed?
Agreed.
Because my address output is there with 50 BTC, so nothing can go wrong for me, right? So I'm happy, even though you haven't done anything positive yet, I'm happy to sign the whole thing, right? Because I know that if it goes through, I'll receive those new coins. If it doesn't go through, I won't have spent anything. So we call this atomicity, right? The idea that all or nothing. So because we have atomicity, it's safe. So when I've done that, at that point, the thing is not ready to go onto the network. I've signed it, but you haven't. So the first input is unsigned, and without all the inputs being signed, the whole thing is invalid. So I simply take all that and give it over to you. I send it to you on a communication channel. You look at it all and say, I receive 50 Bitcoins in the output. Cool, that's fine. It doesn't matter that I'm spending my 50 BTC on the input because I know I'm going to receive it on the output. So then you also sign it, and at that point, the whole thing is signed and it can be broadcast onto the peer-to-peer Bitcoin network, and it will get mined and we get our coins. Make sense?
Yes, I'm with you.
Right, so all of that extends naturally to any number of counterparties. We could do it with 10 different people. We could make 10 inputs, 10 outputs, and let's say, again, that they're all 50 BTC, just to keep it simple. And the same sort of atomicity applies. Each party, when they see the transaction, only have to check that the message they're signing includes a correct output payment to themselves. And note, rather crucially, the cool feature that they don't have to know who's getting all the other outputs. So actually, not only can you do this and gain privacy on the blockchain, but you can even keep a lot of privacy from each of your other counterparties in such a CoinJOIN. It takes some thinking to work out the details, but we don't need to go into great detail. The general idea is that each party only has to check that their output's correct and that their input is what they think it is, and they'll be happy to sign. And when they've signed, they can give it to anyone else, then they can check and they can sign and blah, blah, blah. And at the end of this process, somehow, there ends up with a totally, fully signed transaction which goes out. So that's CoinJOIN. Is it making sense?
Yeah, I got you.
Yeah. Okay, so CoinJOIN. So the problems you have to address in doing something like this is there's a few problems, but mainly it's about coordination. It's about how do we get it so that everyone comes together, meets each other and does this? And how can we make that work trustlessly? Because, pretty obviously, if you had 5 friends and they were all, very tech savvy, then they could all just get together and sort of hack around and do this on their machines and there'd be no problem, right? You gain some privacy on the blockchain. People can and have done this. People have I mean, I know of examples of large groups of people getting together and doing CoinJOINs in this kind of way. But that's not very scalable, right? You can't just work with friends and what have you. We need a way so that lots of anonymous people, ideally, well, very, very preferably, anonymous people across the world can get together, maybe 5, maybe 10 of them, ideally like 100 or 200 of them, get together and make such a CoinJOIN. So people have spent a long time thinking about different ways of doing this. Well, since that post came out, really, in 2013. I mean, probably the first people to jump on it were Dark Wallet. You've probably heard of Dark Wallet, maybe? Dark Wallet?
Yeah, I think, actually, isn't that with Cody Wilson?
Cody Wilson was involved, yeah. I think he was more sort of doing the sort of management and marketing, which he did a very good job at, by the way.
Sure.
But, yeah, it was Amir Taki and some other guys, Pablo, I've forgotten the names. But anyway, so they put this together quite quickly, and they were already doing CoinJOINs, I guess, end of 2013, early 2014. And that was based on one feasible model, which was something like this, that, okay, to get people to do this together, what we'll do is we'll have all the users of Dark Wallet actually, I don't remember the exact technical details of it, but they had a kind of a lobby server. So the idea of a lobby server was you'd connect and you'd say, I'm ready to do this CoinJOIN. So I'm ready to make this kind of payment, and I'll wait for other people who also want to make that kind of payment or make that kind of privacy preserving transaction together with me. And I think they did a model where it was just 2 counterparties, because that's the simplest you could possibly do. So, you can imagine you have some fixed denomination, like you say 0.1 Bitcoins, for example. I say, I'm prepared to do a CoinJOIN. Let's just wait until somebody else shows up. When they do, on the lobby server, when they do, then we'll build this transaction together, sign it, and broadcast it. And so they were doing that kind of thing for a while. Another project that had a similar approach, slightly different though, was blockchain.info. Produced something called Shared Coin or Shared Send. I think maybe there were 2 versions of it. It was similar in as much as people got together on a particular server and produced CoinJOINs. Now, they were larger. They had a model using large numbers. I don't know if it was 20 or 30 different people in the CoinJOIN transaction together, but it was a large number. I remember that the initial version of it had a weakness, which may be worth mentioning, the idea of this weakness, which is that if you do this in, let's say, a naive way, it doesn't really gain much privacy. Imagine this. Imagine I want to pay 1 Bitcoin to Alice and you want to pay 2 Bitcoins to Bob. So Alice and Bob are like the recipients. Maybe they're the merchants, yeah? Or maybe I'm paying... Sure. Okay, you get it. So I want to pay 1 and you want to pay 2. Now, those amounts are not the same. So if we still use this CoinJOIN mechanism, my output is going to be 1 BTC and your output is going to be 2 BTC. So when we make the payment, obviously I'm going to have to produce enough UTXOs to make up 1 BTC, and you're going to have to produce as input enough UTXOs to make up 2 BTC, right? You're going to have enough to make your payment, obviously. So we can combine our inputs as normal, and we can get those outputs. My output is 1, your output is 2. But because my total output will not be exactly 1, I'll also get a change output, a little bit extra. And because your inputs will not add up to exactly 2, you'll also get a change output. So we've already got 4 outputs in that model, right? We've got a 1 out, a 2 out, and the 2 change outputs as well.
Correct.
And the problem with this structure is it doesn't really do anything for privacy. At least that's a slight exaggeration, but it's generally true. Because my inputs will equal to 1 BTC plus my change output, right? Ignoring fees.
Yeah.
We're going to ignore fees in this. And your inputs are going to equal to 2 BTC plus your change outputs. It's like the preservation of money theory. So what that means is that anybody looking at that transaction can easily figure out which output is mine and which change output is mine. You see that the 1 plus this change output equals this set of inputs. They might not know me, but they can make that kind of division, right? They can see that set of inputs paid 1 plus the change, and the other set of inputs paid 2 plus the other change. So they can completely separate those 2 payments, right?
Right.
So you see, that's failed to achieve what the original description, which the kind of very simple description we gave at the beginning. At the beginning, we said one guy puts 50 in, the other guy puts 50 in, first guy gets 50 out, the other guy gets 50 out. But because the 2 outputs were the same size, there was nothing to distinguish them. Yeah. Just like this thing about destroying, we couldn't trace through from the in to the out because there's no way to trace. But the problem is when you use different size amounts, suddenly you're back to square one, because now even though you can't theoretically trace the which input goes to which output, if you can add them up, you can easily find out which ones are which anyway. Do you see that structure?
Yes, I see what you're saying. So, and to go to the absurd example, just for clarity, if you had let's say a 10 BTC input and I had a 1 BTC input, and there was an output there that was 6, and an output that was 6 and a 4, and then a 0.5 and a 0.5. Clearly, like, my 1 BTC input could not produce either the 6 or the 4. Exactly. So both of those came from you, and the 0.5 and 0.5 then by reduction came from me.
Yes, that's a very good observation. That there are like extreme cases where it's so trivial that you don't even need to describe it. Yeah, it's just obviously that you can see which one is which. But I think it's important to observe, because I think people get a bit confused about this point, that even if you build a large transaction, let's say 10 different people or 20 different people making payments, and all of their outputs are very complicated, right? There's lots of different sizes and it's all very even so, theoretically, mathematicians will say, it's an exponential time problem to solve this, because it subsets, we call it the subset sum problem, where you have a set of numbers and you want to know which subsets of the sets are equal. Actually, in practice, it's not really that difficult. So even if you build quite large and complicated looking transactions, it's quite easy for somebody analyzing the blockchain to actually extricate those amounts. So this is a very fundamental issue. I've kind of gone a bit off track because I was trying to describe, like the history a little bit. So blockchain.info, I think, was the second. They had that problem we just described, I think, in their first version of it. And I think, I'm a bit hazy on the details, I think they might have fixed that problem and done a slightly different model of CoinJOIN in the second version. But either way, an interesting sort of non-technical point in the history there is they shut down that service, although it was actually doing quite well in terms of people using it. And the general sort of folklore in the community, because I don't actually know what happened, but the general folklore is, blockchain.info shut it down because of regulatory concerns. So this is something that crops up, that people get interested in this field, but there's, especially businesses, get a little bit wary of getting involved in, even though, to me it's crazy, but all right, they're businesses, they have their own logic. So that was blockchain.info, interesting story that. And JoinMarket, I think, was probably the third significant implementation of CoinJOIN. And basically it was Chris Belcher who, around about the end of 2014, came up with the idea. And the core idea is more important than the details. The core idea is simply that in the models that we've described so far, we've either ignored or centralized the problem of coordination. So in order to get lots of anonymous people together to do it, you've either had to have a specific wallet and have everyone use your wallet and then use a server for that wallet, or we've ignored it. Well, there are some other models where people haven't really discussed coordination, but it is kind of a big deal because, let's say there's a service out there right now and it's like, everyone can do a CoinJOIN for 1 Bitcoin. Well, you have to find people. If you want a large set, we call it an anonymity set of people in the group, you need to find people that are actually going to get involved. So anyway, Chris Belcher's idea was, how about we use a market mechanism to solve the problem of coordination? So in order to, there's a kind of a race condition. I want to do a CoinJOIN when I'm paying for my airplane flight. And I need to do it right now. Because, let's say it's BitPay or something and they have a 15-minute window. On the other hand, there's no, the CoinJOIN I want to do is exactly 0.137 BTC, right? So unfortunately, there's nobody around just sitting there waiting to do a CoinJOIN for 0.137 BTC, let alone, right? You see how ludicrous that is if you actually wanted that. It's just something like that. So the way to make it not ludicrous is simple. You just pay them to do that, right? So to pay them to do that means other people are going to sit in some message channel server something and they're going to just sit there saying, I am ready to do a coin join of any amount you like at any time, but I require that you pay me 0.05% of the amount or whatever, right? So that's how you would create liquidity. I mean, maybe liquidity is a better word than coordination here. Liquidity for coin joins by simply using a market. And so that's a project that's been around for I guess 3 years now, at the beginning of 2015. Yeah, 3 years. It was actually started on mainnet, I think, mid-2015. But anyway, the idea of using a market, it seemed to work quite well. There was interest from an early stage, and the thing about it is that certainly it requires a certain technical expertise to use. I mean, we've improved it a little bit recently, but it's generally clearly the case that it hasn't been there hasn't been a lot of really high quality UI work on it. I mean, most people I think use it on the command line. There is a GUI, but it's limited to the people who pay for the coin joins. We call them takers. There's a GUI for that, but there isn't a GUI for the people who offer the coin joins and get paid. That's makers. So I don't know. I mean, it's been a success and also not a success. It's a mixed bag, but I mean, I've probably done, I was trying to count it the other day. I've done some thousands of coin joins with it. I don't know exactly. There've been academic papers that have estimated it, and because not many people are doing coin joins, it's kind of like the only game in town for the last couple of years. So yeah, unfortunately, I think there was a paper by the Princeton guys, I always forget, Narayanan and some other guys, and they sort of actually have, well, actually there's been 2 academic papers, but they sort of looked at it and said that if people want to do coin joins or Bitcoin, this is what they use, JoinMarket, and they've gone through the algorithm and everything. Oh yeah, I suppose it's worth saying, if we're just talking about the general experience of JoinMarket, is that it started to get pretty popular with a smallest group of people, I guess, in 2016. And as it started to get more popular, we started to see actual attacks. And by attacks, I mean people who were trying to I don't mean people who were trying to steal coins. Thankfully, that hasn't happened yet. But people who were trying to snoop on it, if you want to look at it like that. Because after all, if this is a privacy mechanism, you have to really think in depth about, how are we going to make sure that at every level, you're not exposing data. So people often, or usually, maybe almost always, connect to it via Tor. What do I mean by it? I mean, in JoinMarket, we have to talk to each other, send these signatures across. So we do that with end-to-end encryption over IRC servers, and we use multiple servers for redundancy. And as I say, people actually connect to that over Tor. So there's actually multiple layers of encryption here. And that's all very cool, but, and it does give people privacy in what they're doing, but it does mean that, people can connect anonymously, of course. This system, the kind of philosophical heart of the system is for people to be able to be anonymous. So we're not going to say to people, you can only connect if you're a good actor. Yeah. We can't do that. Because then we would need to start keeping records. People would have to start, have reputation systems and all that. And you could try and do that, but we don't want to do that. So the situation we face is that if somebody does want to disrupt this kind of coin joining going on in this market, they just have to kind of become participants of the market. Either they sell their liquidity for very low prices, or they just try and buy and then they cut out and they don't complete the coin join. So there's various ways you can try and, in quotes, attack it. It's not really an attack in the sense of you're losing Bitcoins. It's an attack in terms of, if they do it right, they're going to try and find out the UTXOs that are used as inputs to all different coin joins. Imagine, you get it, right? So imagine as an attacker, the main thing you can do is, I can try and de-anonymize these coin joins. If I know what every UTXO, who it belongs to, or at least I can trace them through the coin joins, then I can figure out by a process of isolation the remaining one. Oh, that's the guy who was creating the coin join. So it is very complicated. I'm sorry, but I'm trying to give you a sort of general flavor of what the experience of JoinMarket is. But
right. So yeah. I mean, as someone who wanted to do one of these coin joins because you wanted to anonymize this purchase, I mean, that is in a sense, the worst thing that can happen to you. I guess second worst thing being that you lose your coin.
Yeah.
The second worst thing being that you've put your Bitcoin in, you've also paid for this service to anonymize you.
Yeah.
And then one of the people in this party of, has then de-anonymized you or everyone or whatever.
Yeah, I think I probably should have sort of gone from that first principle. Yeah, because a lot of people, when they hear the idea, they say, oh yeah, cool market mechanism. But if it's anonymous, we've got, in quotes, Sybil attacks. So Sybil attacks generally are the idea of, if there's no like real world name tied to something, you can always make lots and lots of fake identities, right? So here that definitely applies, because I just described how our philosophy was to allow anonymity. So obviously attackers can make lots and lots of like bots or counterparties in this market. And people have often said when they've heard the idea, yeah, that's cool, but it's like too easy to Sybil. So the thought is something like, I come along, do a CoinJOIN, but unfortunately, and I choose, let's say, 10 counterparties to do the CoinJOIN with me. But unfortunately, all those 10 are actually the same Sybil attacker. So I don't actually gain any privacy at all from them, because they know which output is mine, because, right? So our feeling by us, I mean, the guys who sort of actually started coding it in 2015 and so on, we thought, well, that's true, but in practice, there's a couple of things to observe. First, if you're doing this, you're not going to make your privacy worse by doing it. In the very worst case, all the other counterparties are owned by one Sybil attacker. But consider, even if there was only one of the 10 I chose who was not Sybil but was an honest participant, then I've still gained privacy, because they still won't be able to distinguish between the honest guy who's helping me do the CoinJOIN and me making the CoinJOIN, because we will both have equal-sized CoinJOIN outputs which are not distinguishable on the blockchain. So it's already broken, just like the Sybil attack is already broken by one honest participant. And it's also amusing to consider, what if there were two groups, let's say the NSA and the Chinese are both on JoinMarket, and they're creating lots of Sybil attackers. They're going to conflict with each other, right? Because if half of them are from the NSA and half of them are from the Chinese, whatever, then they're not going to be able to find out which output is me, because they don't know the other guy, right? So it has to be the absolute most pessimistic scenario for you to not gain any privacy. And then you only don't gain privacy against that attacker, and it's still like everyone else on the blockchain doesn't see the difference. And you're not actually losing anything by doing this transaction, which is why my philosophy with JoinMarket has always been, this is opportunistic. It's an opportunistic gain in privacy. If you want to use it to get seriously improved, let's say you've got some big cold storage chunk of coins and you want to get seriously improved privacy on that whole thing. First of all, you're going to need to spend quite a lot of time, because I can tell you, whatever mechanism you use, you've got to worry about timing correlation. If you've got like 100 Bitcoins and you want to anonymize it, it doesn't matter how clever the method is you have. If you do it all in 5 seconds, people are going to see 100 in and 5 seconds later, 100 out. So you have to use time. You have to split the amounts up. You have to split the amounts up into different pieces, so it isn't at least it isn't totally obvious that there's one input for 100 BTC here and one output for 100 BTC there. So you've got to split up the amounts. You've got to split up the timing. You've got to spend time doing it. So we have an algorithm that Chris Belcher derived at the beginning, devised at the beginning, called the Tumbler algorithm. Tumbler is kind of related to earlier things that were more centralized mixers, and so there. You would try and address those issues. You would stagger the transactions over many transactions, maybe 10, maybe 15 transactions. You would do lots of different amounts going out to different final destinations. You would have it over a long period of time with waiting in between, randomized. And also we use something called, you may not know this, but there's something called HD, like accounts, like BIP32 accounts, which is basically the idea of separating your wallet into groups of addresses. You could think of them as separate pockets, and you sort of move the coins through these different pockets to make sure that you're not like mixing all the coins really brilliantly, and at the end you just reuse the final coin with one of your original coins, which means it's connected anyway, even after all that effort. So you have to avoid that. You have to kind of isolate these pockets as well. So it's pretty involved, but just think of it as like moving coins to this large network of coin joins in a sufficiently sophisticated way that at the end you get something which I will not claim is like perfect privacy. That would be completely wrong to claim that, but it is a heck of a lot better than you might think, actually, if you do it right. That was
a lot of information. Yeah. But that was good.
Well, it's a pretty huge subject. I mean, this is just part of it as well, because there's lots of other kind of ideas that exist for improving Bitcoin privacy apart from doing CoinJOIN in various ways. I think I should go on. Go ahead.
Oh, you may want to take what you were going to say first, but I was going to ask, so you talked about centralized things. So I'm assuming then the way that JoinMarket works is it's decentralized, is users are running their own servers of it, I guess?
Yeah, there's a subtlety here. The problem of coordination is usually solved by having some central server. And the only trick with JoinMarket is that the central coordinator, I'm not going to say server, but the central coordinator is the person who pays. So now that means that as I said before, that person who pays is called the taker. So I, as the taker, will ask for, let's say, 10 people to join me. I'll agree with them that I'll pay them a certain small fee, and it is actually ridiculously small nowadays. I'll pay them a small fee, but the privilege I get multiple privileges. Number one, I get the privilege of doing the CoinJOIN exactly when I want, right now. Number two, I get the privilege of choosing the exact amount of the equal-sized outputs. Remember, the equal-sized outputs are the way we gain privacy. Number three, and maybe this is very important, people don't appreciate it, is I get the privilege of coordinating and constructing the transaction. And because I get that privilege, I actually know, for all the other people in the CoinJOIN, I know where their outputs go. So those other people are getting paid, but they are not getting the same level of privacy in the CoinJOIN as I am. And that's the trade-off, right? But because we do it like that, it makes the coding of it significantly simpler. Now, in terms of servers, I mentioned it earlier, and I'll mention it again. There are redundant, as in multiple IRC servers, but they're only used to pass end-to-end encrypted messages between the counterparties. Well, also to advertise fees, to say, I'll do a CoinJOIN for this fee, but that's public information anyway. But all the actual signatures and stuff, it all goes under encryption. So those servers could be in theory replaced with a peer-to-peer network. To me, that's not a point of centralization. We have multiple servers anyway. But the real point of centralization in the process is that the taker gets to just control everything, and he pays for that privilege. So he's the only one who gets the full privacy effect. Now, I think this naturally leads into the next thing I wanted to say, which is that if we take another model of CoinJOIN, which I'm going to call Chaumian blinding, which was something also proposed by Greg Maxwell in his original post. This addresses that problem of centralization in a different way. And a recent development by NoPara is called Wasabi Wallet. Well, that's what he's calling it now, is Wasabi Wallet. He's just recently released it. Is using this specific method. So let me describe it in very general terms because it's kind of technical. Okay. The idea of Chaumian server is that the server itself does not learn the connections between the inputs and the outputs. This is kind of subtle, right? Because the server does actually construct the transaction. So the server does learn the inputs of the people that connect, although they're connecting over Tor, so it's kind of anonymized anyway. It doesn't really matter in theory. But it learns the inputs. But what it doesn't learn is it doesn't learn which input corresponds to which output. And it uses basically some crypto magic to achieve that, so that somebody connects, provides their input, and then later they reconnect and they provide their output. But it's done in such a way that it's still secure, but the server doesn't know which output corresponds to which input. So that's a different way to solve the same problem that we solved in JoinMarket with a market and saying, well, only the taker gets full privacy. Here, everyone gets full privacy, but there's a centralized server that constructs the transaction and it just doesn't know which inputs belong to which output. So that's kind of cool as well. Yeah. That's Chaumian server. And I should, in all fairness, because, Tim Ruffing's a great guy, I should mention Tim Ruffing, who's a German academic. came up with another way of doing the same thing, and it's called coin shuffle. It basically achieves the same thing where it doesn't use a server at all. Everyone's on a peer-to-peer network, and nobody learns anyone else's outputs. They all have to provide their inputs, but nobody learns whose outputs belongs to who. And again, it's using some crypto magic to achieve that, which is even more complicated, so I won't explain it. Yeah.
So in that situation, is it still like-sized outputs?
Yeah, a good question. All of these models are using equal-sized outputs to gain fungibility. So as we said, I think early on, the problem is if you don't do that, you get what's called subset sum analysis, where you can just split out, obviously that payment went there and that payment went there because the amounts add up. So all of those are assuming tacitly that you're using that equal-sized output model. You still have change outputs, or you may still have change outputs, but that's okay because they only link to the inputs. They don't link to just fundamentally, by the design of Bitcoin, you can't distinguish two outputs if they have the same size.
So I'm going to have links in the show notes for listeners to kind of all of this stuff. We'll find some links so they can read further, and I can read further on this stuff at, let's see, this is episode 25, I believe. So yeah, bottomshelfbitcoin.com/25 if you want to check out the show notes. So what's next? What's developed? I mean, we talked a little bit about Wasabi, like what else is out there for privacy moving forward?
Yeah, there's lots of things that are kind of in development at different stages. I know, for example, that Samurai Wallet has a number of approaches to this, including creating fake CoinJOINs, which is a cool idea, at least as an add-on. I mean, in itself, it's not so amazing, but if it's combined with real CoinJOINs, it kind of is good. That's confusing. If you start thinking about that, you'll really get confused, which is cool. CoinJOIN is immensely confusing. Also, I think they're doing some actual CoinJOIN tech. I think they call it Whirlpool, but I won't say anything about it because I didn't manage to find any documentation that explained the details of what's going on there. But I think it's also
I don't think they've released. I don't think they've released how they're doing that yet, as far as my understanding.
I believe so, but I do think it is using equal-sized outputs. So there's several other things that I could explain as further developments. We may as well just finish off the CoinJOIN part because I want to say a few words about non-CoinJOIN things as well, because it's not just CoinJOIN. But we may as well just finish off the CoinJOIN part by mentioning a recent proposal, which I think is interesting to consider because it's different from all that stuff. And this recent proposal was called Pay to Endpoint. And the idea there is, imagine that you are going to pay someone, your wallet builds a transaction as normal and you're going to pay them. But they also provide you with an alternative whereby you can CoinJOIN with the person you're paying. And this is really cool because, at least theoretically, it's really cool because what it means is that if I'm paying you, but you also give me an input, and then I pay out to you and your output will be how much I'm paying you plus your input, right? Because obviously you have to get your own coins back, right? So in that model, what's interesting is we don't have the subset sum problem anymore. We have a situation where, let me just break it down for you with an example so you see it. Like suppose I've got 5 Bitcoins and I want to pay you 1. And you provide me another input of 2 coins. So I've got 5 as the input. You've got 2 as an input. I want to pay, 1? So I've got to give you 1 plus the 2 you already gave me. So I've got to give you an output of 3. And then I get my change of 4. So in that transaction, it doesn't look anything like a CoinJOIN that we've just described because there are not any equal-sized outputs. And yet we don't have the subset sum problem because we don't have multiple people making payments. So there aren't any subsets. And if there were 2 people making payments, then you get 2 subsets. But there's only 1 payment going on here. So actually there's no problem of subset sum, and we can build a CoinJOIN that just looks like an ordinary payment. In theory, it depends on the details. And this has a number of nice features, such as the fact that because you're producing one of your inputs, because you're using one of your UTXOs as input, you're consuming or destroying that, and then you're creating one new output for yourself. So your net number of additional UTXOs is 0. Do you see what I mean? You've destroyed one of your UTXOs and you created a new one for yourself. Yeah. Does that make sense?
Okay. I'm trying to. I'm a visual person, so I'm trying to draw this out on a piece of paper here.
Yeah, absolutely.
To make sure I understand.
Absolutely. I'm waving my hands in the air to try and sort of visualize it myself. Yeah. So basically, you've got 2 ins. One in is 5, which is from me. One in is, what did we say? 2, which is from you.
2. And the end goal, right? If we were doing a direct payment and bypassing all of this, the end goal is what you're paying me.
1.
Okay.
And so therefore I give you an out of 3, don't I? I give you an output of 3 because I need to give you your 2 back plus the 1 I'm paying you, right?
Yeah.
And the other one will be a change back to me of 4, right?
Okay.
So it balances, right?
Yeah,
you see.
I get you.
And so if you look at that picture, you see that you've put in 1 UTXO and you've taken out 1 UTXO. So the net change in your number of UTXOs is 0. You've destroyed 1, you've created 1, yeah?
Yeah.
Right, and that's different. Notice, if you're a merchant and you're receiving payments, every time you receive a payment, you have to get a new UTXO, don't you? So if you're like Coinbase and you receive, 5,000 payments in a day or whatever, you've suddenly got 5,000 new UTXOs that you've got to deal with. You've got to consolidate them, or you've got to worry about them, whatever. Here, you don't. You actually just keep the same number of UTXOs, which is really cool. I'm only saying that. That's a kind of a technical thing. Or maybe the listeners are not actually interested in that. But I think, it's kind of like, if you're a merchant, that would be an interesting feature. That's something to bear in mind. But generally, the idea is there are 2 nice things about this. That it's a CoinJOIN, which means I didn't actually talk about this. Maybe we should talk about this. It breaks wallet clustering. We'll talk about that next. I'll explain what that is in a minute. It breaks wallet clustering, and the cool thing is it doesn't look weird. It doesn't look like a CoinJOIN. It just looks like a payment because, by the way, maybe that one doesn't because it depends on the amounts, but usually it will look like a payment because it's very common for people to make payments with 2 UTXOs. They often don't have everything in 1 UTXO. They often need to consume multiple, yeah? And every payment has 1 output and 1 change, or almost every payment. So it looks totally normal, right? Which is really fantastic because what we want to achieve ideally is we want to achieve mechanisms that improve fungibility but are not obviously flaggable as a particular type, which then, people who are doing chain analysis can start saying, we'll look at those, they're different, we can separate them out. We want them to be confused, basically.
Right.
Okay, so there are a number of problems with that proposal. I think it's a little bit limited, but it is a really interesting proposal. Let's say that. Now, I do want to talk about wallet clustering because that's kind of fundamental to all this. So what is wallet clustering? Generally, the idea is that if you want to trace the ownership of different coins, obviously at the base level, it doesn't work. If people don't reuse the same address and again, then you're just seeing, this coin went from this address to this address, then it went to that address. And if every time it's new, you're not learning anything. So obviously people who try to do what's called blockchain analysis, have to make some assumptions. And the most the cornerstone assumption, at least it has been, that when you see a transaction that uses multiple different UTXOs on the input, you assume that they're all owned by the same person. And that's actually a very powerful assumption if it's correct. If it's correct, then every time you see 2 UTXOs used in the same transaction, you can assume they're the same, but that's transitive. In other words, if you then see that an output from that is co-used with another output in another transaction in the future, then they all end up getting into the same group. And then that continues. And what you see, if you look at websites like walletexplorer.com, or nowadays I think oxt.me does this as well. There are some public websites that do this a little bit, is they will show you big groups of addresses. And they'll say all of these addresses we deduce are actually owned by the same party using this wallet clustering heuristic or assumption that, two things, if they're using the same inputs in the same TX, are the same owner. So they use these heuristics to try and generate these big clusters of addresses that are all owned by the same counterparty. And that's certainly not the only thing they do. They have several other tools of the trade that they use to try and associate addresses and say, oh yeah, they're both owned by the same person. But it's like the main one. And the good thing about CoinJOIN is it breaks that assumption. So when I go on to I'm not sure if Wallet Explorer is really working. I think it is still working. But if I go on there and I put in one of my JoinMarket addresses, it's kind of broken, right? Because it's got two choices. It either uses that assumption and assumes that every input that is co-used in the same transaction is owned by the same party. Then it gets the wrong answer, because what it gets is a huge cluster of addresses of me plus all the other people that I've done CoinJOINs with. It actually becomes huge, yeah? And it gets bigger over time. Yeah. Or they either make that assumption, or they look at the transaction and say, oh, that's a CoinJOIN because it has equal sized outputs. And if they flag it as a CoinJOIN, they can just say, well, you know what? We don't know who the inputs are there. So we're just not going to include that in our analysis. So in that case, obviously that's a win as well. But even better is if we make these kind of CoinJOINs which don't look like CoinJOINs, because then they have no choice. They either throw out the common ownership assumption entirely, or they admit defeat. So there's lots of details to how blockchain analysis works. I think it's fair to say that I'm pretty sure it's fair to say that people are overestimating the power of it nowadays. A lot of what those companies, I think, are doing is making kind of real world connections. So they're doing things like going on exchanges and saying, this exchange's records tells me that this address was the coins came from this address, and then maybe 6 months later they try to trace through and they say, well, 80% of those coins ended up on Coinbase or Binance or something, right? So that's a kind of it's not really proper blockchain analysis. So I think what they're doing is a mixture of all different techniques. They can use timing. They can in theory use the peer-to-peer network as well. They can try and look at stuff happening on the Bitcoin network. I mean, that certainly is happening. There are Sybil nodes on the Bitcoin network that are trying to snoop transactions. So they've got lots of vectors of attack. But this specific thing of tracing on the blockchain is at least heavily damaged by CoinJOIN, at the very least, I would say.
Yeah.
Yeah. So, yeah, we've talked for a long time about CoinJOIN.
That's all right. It's good stuff. And we also talked a lot about fundamental ideas of UTXO sets and change outputs and things that I think really are kind of that next step of understanding for a lot of people. It is confusing. Like if I was going to go talk to my dad about Bitcoin, which is, I mean, he's just not there. I gave him my copy of the Bitcoin Standard. He's reading through that, so I'm hoping he's going to get something out of that. But I would not start with UTXO sets. It's not where I would start.
Absolutely. And the nice thing is, if you think about it, probably this is optimistic, but let's say in a year or two, Lightning gets a lot of traction and wallets, all the ordinary people's wallets have Lightning, then they'll never have to learn about UTXO. Just like today, I mean, who knows about TLS record formats or TLS cipher suites or something? I mean, the core level protocols or HTTP or TLS, those things or IP that are used every day by everyone. I mean, nobody knows how those things work, and that's fine, right? I mean, the good thing about Lightning is UTXO is totally abstracted away. It's irrelevant. Well, maybe on channel open and close, but when you make a Lightning payment, there's no involvement of UTXOs. It's a clunky thing, but I think it's clunky, and it is clunky, but it's there for a reason. It's important for state isolation or something for scalability. Well, this is one of those very big debates in the blockchain world. UTXO model versus account model, but again, as you say, nobody wants to know about all this stuff. They just want to make a payment, right?
So let's talk for a second, though, about these ideas of UTXO bloat and UTXO consolidate. You were talking about Coinbase and merchants having this, and when you were talking about
the pay to endpoint,
the pay to endpoint. That's right. So you are creating a new UTXO every time, and the UTXO set has to be kept by every node, right? Yeah. So there's this trade-off of creating a bigger UTXO set has the potential to increase privacy, but you're also kind of creating a bog down on the network potentially as well.
It's an important observation that and I think this is, I won't say it's totally generic, but it's quite a generic observation that a very large swathe of different privacy technologies, and not only in Bitcoin, by the way, but a very large swathe of them operate on a kind of noise principle where you create a lot of other stuff to prevent the actual signal of, like, in this case, the signal is where your coin's going. Yeah. We're trying to prevent that signal being readable from all the noise around it. So that's a crude way of putting it. But in the case of an equal amount CoinJOIN, you're creating multiple equal amounts to try and obscure who. And you're right. I mean, generally speaking, if people use something like JoinMarket at large scale, it would mean huge amounts of extra space usage precisely because of it's intrinsic to the model. The model is that other people help you do your payment. So they make what are effectively fake payments to themselves of exactly equal the amount of your payment. And so that is a lot of extra UTXOs being created in each JoinMarket transaction. So you're absolutely right that these kinds of privacy technologies that create larger, that use noise effectively are scalability losses, and we're not going to be able to do that at huge scale anyway. So maybe this is a natural lead-in. Perhaps this is the last area we could discuss is like the non-CoinJOIN approaches to privacy in Bitcoin. Should we go that direction? Unless you've got more questions about CoinJOIN, I'm happy to answer them.
No, I think we've covered that pretty sufficiently, at least for an audio format. I think to go beyond that, we're going to have to use diagrams. Right. So probably not the best format.
Good question. Good question about scalability. It's absolutely spot on. Yeah. Okay. So I'm going to talk about. So I think we should talk about the other approaches to privacy that people have looked into. At least let's confining it to Bitcoin for now, although we could talk about altcoins as well. So in Bitcoin itself, there's a whole set of stuff. I mean, I think the first building block that people, if they're interested, should think about is the atomic swap idea. So the atomic swap idea is it's possible to make two. We talked earlier about how a CoinJOIN is atomic because a Bitcoin transaction is atomic. It either all goes through or it doesn't go through at all. So it's kind of safe like that. So what an atomic swap is, it's trying to extend that over more than one transaction. And the idea is, just very vaguely that there's some kind of secret value. And when one of the transactions is broadcast, the secret value is broadcast, and that's what unlocks the other transaction, so it can also be broadcast. So given that mechanism, you can effectively make transactions be not just directly on chain, so to speak. So one way you could use that is you could, with a little bit of clever shenanigans I don't want to go into, basically make it so that I pay you 1 BTC in a transaction, and you pay me 1 BTC in another transaction, completely separate with different histories. The two transactions are atomic, but we can make it so that there's no weird custom scripts or secret values like hash values on the, in the transactions. So it's not possible to, when somebody looks at the blockchain, they'll obviously see all the transactions, but they won't see that those two transactions are obviously linked. Now, to be fair, they are kind of still obviously linked if they both have the same output amount, 1 BTC. That's arguable, but it is a very important consideration. So it is possible to do that. And if you think about it, actually, it's not so easy to understand without sort of going into a long description, but you can imagine, I hope at least, that achieving privacy that way might actually use a lot less space on the blockchain. Because I described how, like, if you want to do CoinJOIN properly or JoinMarket, you need some mechanism where you go through multiple layers, pockets, different amounts, and different timing and so on. So yeah, I mean, I don't want to like say it's a brilliant idea, but you certainly could try to gain privacy, and we call that kind of coin swap. That idea that you could gain privacy by just making two transactions atomic. So what it kind of ends up is with your one Bitcoin having my history and my one Bitcoin having your history. Okay, so that's kind of cool, but there's all kinds of like details there we're not going to go into. But the same idea can be extended in the way that it can be done off the blockchain, and that's what Lightning Network fundamentally does. I mean, Lightning Network is kind of a combination of two clever ideas. One of them is the payment channel, where you update transactions to give the other party more and more money over time, let's say, or vice versa. But then there's the other part, which is the routing of transactions through multiple hops. And that part uses that atomic swap idea. So we can gain privacy by using this kind of atomic swap approach, where the final like destination of the coins, let's say after you've done stuff on Lightning and it comes out onto the blockchain, the final destination of the coins is unconnected on the blockchain's own history from the original payment of the coins. So that is obviously a very powerful idea for privacy. And Lightning Network at the moment is like the canonical example. It's the one that has the full like fleshing out of the idea. So a lot of people are quite excited, and I think quite rightly, about Lightning itself as a way of improving privacy. It has like trade-offs, but I think we could say that for ordinary everyday payments, the trade-offs are heavily in favor of using it. So that if you make lots of little payments, doing it this way involves no permanent blockchain trace. If you want to use Lightning for very large payments, or let's say for kind of, if you wanted to use it to kind of effectively mix some large block of Bitcoins, people have been looking into that, but I suspect they're going to find that there are some downsides. The thing about Lightning is you have to have capacity in the right places in order to make a certain payment work. So if I just want to move my coins into Lightning Network in one location and out at another location, I have to have the capacity in the right directions on each side, inbound on one side and outbound on the other side. So there are complications there. The other thing to observe about Lightning's privacy is it's a very different whole scenario from what we're used to with Bitcoin. So there are roots which are public, and there are amounts which are public. There are also issues like if you have, especially maybe if you have short roots, you have to think about Sybil nodes. You have to think about what if somebody's trying to use their channel to snoop. You have to look at the fact that the pre-images that lock together all the hops on the root are currently at least are the same value. So there's possible linkage there. And there are other things too. I mean, the fact that it's an online protocol, so people have to be kind of connected online. I could probably, there are probably other things you could say, but overall, it seems to be a really excellent model, at least for ordinary everyday payments, but perhaps not for like your cold storage, right?
Sure.
So yeah, I mean, there are other, maybe just finally mention a couple of other like ideas for privacy that are very promising in different ways. One of them is confidential transactions. So confidential transactions is like very simple to explain its intent. Its intent is simply to make each output amount on the blockchain be blinded and be invisible. And the alert listener who's still listening after all this time, well done if you're still here. The alert listener will notice that solves a whole bunch of the problems that we discussed early on. Yeah. So we discussed the problem that if we want to make the output amounts equal, we have the problem that we have to coordinate and find lots of other people who are prepared to do the CoinJOIN of that exact amount. And we discussed the problem that if the output amounts are not equal, then we get something called subset sum analysis, which kind of immediately removes the privacy effect. So confidential transactions would solve that. So it's important to understand that confidential transactions would be very much kind of would naturally marry together with CoinJOIN. The two things together are extremely powerful because it would mean that I could make a payment and you could make a payment, any payment of any amount. We could just do it together in the same transaction and nobody would have any clue that it was happening and nobody would be able to disentangle which payment went to which destination. So confidential transactions would be an extremely powerful improvement to Bitcoin's privacy. Unfortunately, it is a very big change in Bitcoin. It has been implemented by Blockstream in their Elements project, I think initially in 2015, and it is, I think, currently coming into a live state on Liquid around now. So that's cool. It's also live on the Monero blockchain. They implemented CT, the same, almost exactly the same crypto stuff in it. Sometime recently they implemented it, maybe last year sometime, I think, yeah. So it's there, it's really cool, but it does require kind of a very big change, and there's some debate around certain details around it. I won't get into it, but there's some debate about, yeah, go on.
Well, so how does verification work then if if a node can't see?
Right, good question. So fundamentally, it's based on an idea called a homomorphic commitment. And what that idea is that when I take a number A and a number B, obviously if it's plain text, I can just add them up. But if I hide each of them, I do some operation on A and I get blinded A, and I do some operation on B, I get blinded B. Those two blinded values have to be totally random, right? So how can you possibly know that when you add them together, you get the right output? Yeah. Well, the answer is that there are certain forms of blinding that preserve the property of addition. So even though A is no longer, let's say A is 3 and B is 7, just to make it concrete. So 3 gets replaced with a random number. Actually, it's a huge random number, like 32 bytes, right? But 3 gets replaced with a random number, B gets replaced with a random number. And then I output a random number that I underneath the hood, like before it gets blinded, I take the 3 and 7 and add it to 10, to get 10, and I blind that and I make another third random number. But this special kind of randomization has the property that the randomized forms add together to give the right random output corresponding to 10. So even though you don't know what you don't know what numbers those random values correspond to, you know that they add up to the right random number. Do you see what I mean? Is that that's much easier on a whiteboard than
Right. Well, that's why I've got my notepad out here. I'm writing it out. Okay, so let's maybe we can say it this way. Yeah. So we have inputs of 3 and 7 that correspond to A and B. Before we randomize them, we add them together. We know that makes 10. We assign that as C. Mm-hmm. So we know that. Then then once we randomize all of that, we know the program knows, or the software, whatever, understands that randomized A plus randomized B equals randomized C.
Very good. Yeah, I was going to say using function like FA plus FB equals F brackets A plus B, but your way of saying it's better. Randomized A plus randomized B is equal to randomized A plus B, and that is verifiable publicly, yeah. And of course, it's absolutely critical that we are sure that equation, randomized A plus randomized B equals randomized C, only holds if A plus B equals C, yeah. We have to be sure that that's true, otherwise the system is not secure. And there's been some sort of, maybe it's too theoretical, but there's been some debate about, the exact cryptographic assumptions behind that statement. Because the problem is, if that statement is not true, that if it was possible for an attacker to come up with some weird values of A, B, and C, such that even though A plus B is not C, nevertheless randomized A plus randomized B equals randomized C, if he's able to do that, then he's able to print coins, and even worse, he's able to print coins in a way that nobody else knows it's happened. So did you see the point? Yeah. So the blinding effect it's almost like it ratchets up the security requirement, So I feel like it's not really correct to say that, as some people say, that, oh, well, it's okay because it's the same assumption. I don't want to get into this. I've gone too technical. Sorry. But you've got the basic idea, and it's important to observe that also that confidential transactions, in exactly the same pattern as I've already mentioned with CoinJOIN, that the addition of noise makes it use more space. Because you randomize, let's say, the number 3 into a 32-byte random number, it has to be a large random number, otherwise it's too small of a group and somebody can just figure it out by brute force. So you make these large random numbers, and actually you do a hell of a lot more things as well. I won't go into it, range proofs, whatever. It means that a confidential transaction uses more space than an ordinary Bitcoin transaction. And so consequently, that's another kind of trade-off one has to bear in mind. I mean, in Monero, for example, they just accept that and they just make very large transactions.
Gotcha.
Yeah. So confidential transactions is another very interesting potential. We'll see. Well, nobody really knows if it's ever going to be part of Bitcoin or not, or, there's always the sidechain thing as well. I'd love to see it on a sidechain, but we don't seem to have a good sidechain mechanism. That would have been my ideal scenario, because then we could use it, but, we isolate it somehow. Because, scalability and also potentially security, but mainly scalability is an issue. So that's one angle. The other angle, which I think is less known by the non-technical community, but which I personally think is very, very important, is within the whole thing of Schnorr signatures, which the cool thing about Schnorr signatures is they're a scalability improvement. Okay, because if we can use them in the aggregated form, the basic idea, to get rid of all the technical mumbo jumbo, the basic idea is that multiple signatures end up being squashed into one signature. And signatures are big. They're like between 64 and 73 bytes, depending on how you encode them. So you've got this big object in a Bitcoin transaction, and you've got lots of them at the moment. Some transactions even have like 50 or more. But you don't want that. What you want is just one signature. That would be cool. That would save so much space. So although it's a bit complicated, we're moving hopefully towards a world in which we use Schnorr signatures for transactions and we save a lot of space. But the fantastic thing is, because they have another property, which we call linearity, it means that we can do a lot of clever tricks with Schnorr signatures that we can't do with the current ECDSA signature. And what Andrew Polstra, who's also a Blockstream guy, he's been looking at this for some time, and he's come up with this idea he calls scriptless scripts. It's a kind of a funny name. But what he's really talking about is how you could embed logic like we currently have in scripts, things like, multi-signature or hash time not contracts, which is the atomic swap thing. We can embed at least some aspects of those scripts inside signatures in such a way that A, they don't take up any more space, and B, they're totally invisible to the outside world. They're not just invisible in the sense that you can't see them without doing a lot of computation, but they're invisible in the sense that it is theoretically impossible to find them. Because I can always assert that any given script that I'm coming up with that I've embedded in this signature is there, and I can, in quotes, prove it to you by producing a number. But actually, so could anyone else, and they could produce a different script and prove, in quotes, to you that script was embedded. So in a fundamental sense, they're completely hidden. So a concrete example, because that's a bit abstract, but a concrete example of what I mean is that what I described to you earlier as a coin swap, where I pay you 1 Bitcoin, you pay me 1 Bitcoin in different transactions that are not connected on the blockchain. And we can do this in the Schnorr signature with this script mechanism, where basically the secret is embedded in the signature. And when you broadcast your transaction, I, and only I, can extract that secret and broadcast my second transaction. And all of that can happen just with a single Schnorr signature on the blockchain, which just looks like any other transaction, and it doesn't use any more space. So this is one of those few cases where we, as I put it, we cut the Gordian knot of scaling versus privacy. Yeah, because what I described earlier about that mechanism of you usually gain privacy by adding noise. There's actually protocols it's called Vuvuzela, which is kind of a funny name, like that South African, that South African thing where it makes noise, Yeah. The Vuvuzela protocol is an idea where you just add tons and tons of noise to the traffic on the network to make it impossible to find the signal. So it's the same thing here. But we can cut that Gordian knot. We can gain the privacy without adding all the extra data, which uses up blockchain space, if we can take the atomic mechanisms off the blockchain. So Lightning does this, right? Because it has these off-chain routing, which sends coins between different participants without anything on the blockchain. And the same thing here with scriptless scripts, which is the idea that You embed the data in a signature without taking up any more space. It's effectively off the blockchain. It's a negotiation between you and me as participants. It's still cryptographically secure and it hooks into the blockchain, but it doesn't actually use up transaction space. So those kind of angles, I think, are the right ones to be aiming for. Yeah, by which I don't mean that I think CoinJOIN is kind of fundamental, and I think CoinJOIN is going to continue to be an important part of the mix. CT, or confidential transactions, we really hope it will happen, but there's kind of question marks about how it will happen. Even though there's been big improvements on it recently, Bulletproofs, you've probably heard of, is an improvement that squashes down the size of confidential transactions, but they're still bigger than ordinary ones, at least. Well, again, it kind of depends if we aggregate them. That's a whole other discussion. So there's CT's cool, but I really like off-blockchain stuff. So Lightning is really cool. So, it's kind of a complicated picture I'm painting, right? There's multiple different techs. Some of them are already deployed. Some are kind of being deployed, and some of them are still in development. But they're all good. And I would just, my final thought for people would be just like, don't assume that Bitcoin is perfectly traceable. I mentioned Andrew Polstra earlier, and I think I've already said this on another podcast, but I'll say it again. He gave a talk in Boston recently. And the last line of his talk was something like, if you're doing blockchain analysis, you're lying to yourself and others. And I think people should seriously consider what he's getting at there, which is that actually, not only because of things like CoinJOIN, but because of things like what I just described, things can be happening on the blockchain and you don't even know it, that are actually breaking the history. And all your assumptions about tracing coins could actually be quite invalid. Even today, even with ECDSA pub keys, you can use two-party computation to do scriptless scripts. So it doesn't even have to be waiting for Schnorr. And Lightning, of course, as well. Stuff is going on in Lightning and you don't know about it. So
yeah. So do you think we'll get to a point where everybody's running these privacy, or maybe not everybody, but enough people are running these privacy mechanisms to block, to frustrate blockchain analysis? Or do you think we'll get to a point where it's just so obvious that, I've talked about to people about the idea of tainted coins, right? Which is kind of ridiculous in the sense that every coin at some point is tainted. We don't check dollar bills, and when they do run them, every $20 bill has traces of cocaine on it. Do you think we'll get to a point where they just give up on because the mainstream realizes that everything is tainted, or do you think we'll if we want privacy, we will still have to keep making these efforts and striving forward and pushing the next thing?
Yeah, it's a difficult question. I'm really not sure. I think it's worth observing that the current status quo is quite bad, but it's not so much bad because of the tech, although, the tech is, we don't have really good tech yet for privacy, but it's more bad just because of the way people use, or rather don't use, Bitcoin. I think the typical usage pattern for a lot of people is just, take it, buy it on an exchange, and either just send it to a cold wallet. Well, obviously that's safe. If you're not going to use it, there's no issue, right? or they send it to, they start buying altcoins and they send it from ping it between one exchange and another, and that's all they ever do. And the problem is, of course, all these exchanges are under increasing pressure to be totally KYC'd, AML'd, even way further than ordinary businesses. And so it's just completely irrelevant what kind of privacy tech you've got on your coin, if that's all you're going to do, right? So the real issue is if we start using Bitcoin in peer-to-peer trade, I think people might be surprised the extent to which actually it's extremely difficult to keep track of it. To give an example, I think sometime in 2016, there was a message on the JoinMarket subreddit from a guy who he was running some kind of exchange or some kind of smallish exchange or something. And he'd got stolen. He had stolen 450 Bitcoin. And then, it was a large amount. But of course, at the time it was stolen. It was stolen in 2015 when the price was very low. So it wasn't quite as large as you think. And he came on the JoinMarket subreddit, or Bitcoin subreddit, I think, and said, can anybody help me trace these coins? And we all looked at where the coin started, where the hack happened, and We said, oh, well, actually, that's JoinMarket, because it's pretty easy to identify JoinMarket because of these equal-sized outputs, and we said that's JoinMarket, but as far as I know, nobody was able to trace the final destination of those coins, and that's an anecdote. But I think people just tend to assume that everything's easily traceable, whereas actually there's an awful lot of stolen coins that never got pinged, and usually people who get caught, it's usually because of off blockchain stuff. You could call it metadata. It's where they sold it on what exchange. It's their name. They bought a house, whatever. People occasionally you see stories of people getting there's a court case and here's where the coins went on the blockchain. And usually it's just because they didn't do anything at all. They just sent it from their wallet they withdrew it from an exchange to their wallet, and then they sent it from their wallet to another exchange, and then they expect it to be anonymous. Of course it isn't, right? So what I try to get at is the long-term vision is very difficult to be sure what's going to happen. In an optimistic scenario where Bitcoin is used as money, and at least some of the tech that I describe is used by at least some of the people, I think it will be very difficult to create some kind of panopticon over the whole blockchain. But in the pessimistic scenario, people are just going to speculate with it, and then it just doesn't really matter how clever you get with the crypto. It's just your name is attached, so that's that. Yeah, it's hard to say. It's a good question, obviously, but I don't really know.
Well, yeah, sure. I'm asking you to predict the future.
Yeah.
That's not possible. Yeah, it was an impossible question. So, all right. Well, Adam, how can people keep up with you in the work that you're doing?
Well, my name is Waxwing on IRC Freenode and on Reddit, although I don't use Reddit too much nowadays. I'm also Waxwing with 2 underscores on Twitter, and I'm Adam ISZ on GitHub, just to be different. So that's that, really.
There you go. Are there needs?
I should mention my blog as well. I update it extremely erratically, sometimes 3 times in one day and sometimes not for 6 months, but it's it's joinmarket.me, or it's https joinmarket.me, and it's /blog should I hope take you there. Yeah.
Okay. But while you mentioned GitHub, then are there needs within JoinMarket? I always like to, when I have someone on that's doing a open source project like this, I like to just kind of air out hey, we need this or that, or we're looking to expand this or whatever. Do you guys have active, issues that you're wanting to work on that people could come help with?
Yeah, there's lots of need to improve. I mean, there's loads of areas that it needs improvement. Maybe Python 3 upgrade is one. So I guess anyone who's got good Python skills might want to, if you've got time, and you might want to get involved, and it may need actually there's a to-do list. That's a good thought. There's a to-do list in the docs directory, and if you read that to-do.md, maybe it'll give you some ideas on how to contribute. Yeah.
There you go. All right. Well, we can include that as well in the show notes. So
thanks. That's great.
Yeah. bottomshelfbitcoin.com/25, everybody. And anything else you want to say before we?
No, that was great. Thanks for having me. It was interesting. Yeah.
All right.
Thank you.
Thanks for coming on. All right, Bottom Shelfers, that's going to do it for our show today. Remember to subscribe to the podcast so you don't miss a single episode. We're on iTunes, Stitcher. You can just follow the RSS feed, however you like. Share the episode with your friends and families and those people that you annoy because you're a Bitcoiner and they're not. And make sure to give us a good review on iTunes and Stitcher and whatever other rating systems there are. That helps other people find the podcast, and then that helps me. If you want to support the show, I've got Bitcoin donations through a Payname address that's on the website. I've also got a BTC Pay donation page set up there as well. And if you want to use fiat, you can use Patreon. You can do one-time or monthly payments through that. And let's see what else. Tuttle Twins books, bottomshelfbitcoin.com/kidsbook. I've got a link there, and then whatever you purchase from the Tuttle Twins site, I get a chunk back from that. So that's really appreciated, and you're getting a great book from there. So yeah, follow me on social media, Bottomshelf BTC on Twitter and Instagram, and then I'm also on Mastodon. I'm Bottomshelf BTC at bitcoinhackers.org. And then I'm catching up on getting my episodes up on YouTube. I saw someone saying that they appreciated some of these some audio podcasts being up on YouTube so that they could use the translate feature. So I am working to get my back episodes. I had a couple that I hadn't gotten up on YouTube yet, so I'm working to get all those caught up. So yeah, if you're an international person and that's something you appreciate, let me know. That helps me know how I can help you. Help me help you. Anyways, okay, and I guess that's gonna do it for our time together this week. Make sure and tune in again next week, and I will see you then. From Bottom Shelf Bitcoin, I'm Josh Humphrey. Thanks for listening.